Hello everyone, thanks for joining the webinar Kubernetes Masterclass. This is Chaitanya Argatula. I am from India and I work with the InfosecTrain, who are the top security and technology training and consulting organization. They worked on multiple security-based industry they are in, and we are going to do a training. So very brief about myself. So I am a trainer and a consultant with Infosec. Yeah. I've conducted lots of trainings on cloud, DevOps, Dockers, and Kubernetes. I'm certified in these technologies. And today we are going to learn about Kubernetes, very brief. So this session is recording, and you also get in these link for later review. You can also see it in YouTube. Who registers with InfoSec, you also get in an email using which you can see the information. I request everyone to be on mute. Have your questions? I'll pause after a few slides. You can ask me questions. I'll answer your questions. And at the end, again, we're going to have an FAQ session in which you can ask me all the questions. And for more information, you can contact. And at the end of this session, I request you to provide your feedback, which is very valuable for us. You'll also get a certification of from InfoSec once you are done with the session today. So what this session is about, it is all about, very brief about Kubernetes. What is Kubernetes and why you want to use Kubernetes? That is the topic which we're going to talk about today, very brief. So the agenda for today's session talks about what is container orchestration, why and what is Kubernetes, architecture of Kubernetes and different components of Kubernetes, and very brief about pod, I'm going to talk about, and how to create and manage pod using different commands in your Kubernetes. In the end, we're going to have a Q&A in which you can ask me questions about what you learned. We'll also talk about the upcoming classes, curriculum details I'm going to share to you, and the dates, and how you can register for that. I'm going to talk about all these things in your today's session. So let's start. The first one is, what is container orchestration? Now, in enterprises, you need to manage multiple servers. So if you want to manage multiple servers of Docker, there must be a mechanism as to how you can create containers inside those servers, how you can do a load balancing of the containers, or how do you define where you want to have your containers to be deployed, how do a monitoring of it, securing it. All these are the concept which is required for managing containers. And for managing this, there are lots of software or tools to be used for managing containers. We talk about containers, it means that it has only the application. So how do you manage containers orchestration? The different tools are Docker. So Docker is the tool using which you can manage. So you have native of Docker Swarm. You can use Kubernetes, which can support any type of container platforms. So in enterprises, there are different types of container platforms. One is Docker is the basic, which you hear more. You also have in companies like CRIO, Linux containers, different types of container platforms are there. And if you want to manage different types of containers platforms together, you want to use Kubernetes. And you have Rancher, Meso, the list keeps on going. So today we're going to talk about, very brief about how you manage your container machines, that is multiple servers which are running containers using Kubernetes. So what is Kubernetes? So let me show on a high level what we're talking about. So we're talking about something like this, in which I'm going to have in an orchestration. Or what is orchestration? It means that I can have in multiple machines. This is one, and this is one. How do I manage containers running inside this? This is what I'm talking about for orchestration. So for doing this, there are different methods. Docker Swarm and Kubernetes is quite predominant. So Kubernetes is open source for managing containers across your environment. And how do you manage in your Kubernetes? You can collate the containers into something called as a pod. And is a product of Google initially, and is right now a product of CNCF. So it gives you lots of options to manage your containers, orchestrate, load balance, schedule them, and ensuring it's always running. Lots of options you're going to get using Kubernetes. So let's see the website of Kubernetes. Website of Kubernetes. So Kubernetes is also known as K8 is abbreviation, open source system for managing and containers. So what are the containers? In case you're new to containers, let me talk about Docker container. And what's a container? So what's a container? This is a container. So all these are containers. So the containers do not have any OS inside them. This is your container. This is a container. These all are containers. And for managing containers, you need to have some platform. So that is the Docker. So like Docker, you have different platforms. How do you work with containers? For example, I want to create a container. I would install Docker on my machine, maybe a VM, install Docker. And then I pull in the images for an application like Apache, for example. I pull in the image and then create a container, which application, it has application up and running. So everything was required for a container. The application, everything is there inside this container. That is the library files, registries, everything is there. We can start using an application quite quickly. This is called as a container. So container is all about how you could start your application quite quickly and very portable. And this is a standard terms. So it's a standard, very lightweight because it does not have OS. It's very secure. It directly works on Linux kernel. So how do you manage these type of boxes in your enterprises? That is what we're talking about, orchestration. So very brief about containers. So how do you manage those type of boxes if you have different type of container platforms as your Kubernetes? So it's product of Google initially, and very, very stable, very secure, and it could run on any platform. It can run on-prem, it could run on the cloud. Example, you have lots of cloud services like AKS in Azure, or in Amazon, you have EKS. In Google Cloud, you have Google Kubernetes Engine. So many cloud providers helps you to work with your Kubernetes quite easily. Either you can do it on your own machines, that is, I'm talking like an infra as a service, or you can also choose platform as a service when you work with Kubernetes. And lots of customers, they have started migrating to Kubernetes. So what are the important features of Kubernetes? One is it allows you to easily deploy your applications or making modifications or rollbacks. I can have in my storage to be increased automatically by using storage orchestration mechanisms. I can define where I want to deploy my containers based on requirements. It supports both IPv4 and IPv6 options. Self-healing. The self-healing, it means that if for one of the reasons container is going down, you could configure such that it can come up automatically without any human intervention. Similarly, you can define load balancing parameters and how do you want to access your data. For example, any containers do not have a persistent or a elastic IP, for example. How you can use it using service discovery, how can you access your application running in the back of just service discovery and load balance I'm talking about. Any information which is very critical, database passwords, all this thing, you do not want to save it in a main file. So you can have in a separate configuration file, which you can map it and you can use it within your containers or pods. Similarly, you can do auto scaling and other features. So lots of features which is required for latest applications, which needs to be very faster and more secure. Kubernetes is the right use case. And lots of companies, they've started using this. Examples very long. Lots of companies, they use it and they found Kubernetes to be a very, very good platform. And it's a part of CNCF. So very, very brief about what is Kubernetes. What is Kubernetes? The basic. Now, why are we using Kubernetes? So we can think about before 30 years, all were physical hardware. And it's fine, no challenge. But later, the lots of issues came in as to how you could utilize lesser cost, how the data center costs were very high, and lots of applications, the underlying server were not completely utilized, lots of wastage. So the concept of virtualization came in wherein you install something, the servers, they were used to install hypervisors like VMware, Hyper-V, Zen. These are different type of hypervisors. And these hypervisors abstract the underlying layer and you can create multiple VMs on top of it, which increase the utilization of underlying hardware, and each VM can work isolated. Now, the generation came in wherein still the VM has some challenges, wherein the operating system is a challenge. Now, example, in your Windows VM, the operating system takes more space rather than application. And when you go to cloud or any paid services, you get charged for the size of the VM. Licenses cost for Windows licenses. What about the operations performance? The boot time takes a very longer time to boot. You have to upgrade it, the OS, lots of patching, so many things are required, and it's quite bulky. How you can make it much more better, because the ultimate objective for application is it must be up and running quickly, and the changes must be done very fast. That is the expectation in a DevOps environment or world. So that is where the containers came in, wherein you can have in a container runtime environment like Docker, you install it, and you create containers which does not have an OS. Because it does not have an OS, it uses a shared OS. It uses the host OS. Since it does not have an OS, it is quite lightweight. It is quite faster to start and stop, quite portable to any environment. So in a DevOps world, for example, I can have a common repository in Docker Hub wherein each one can, for example, developer would create a container, he'll do the work, and then push it to a repository in Docker Hub, and then the next person download it. So it's very portable, very easy to start using in DevOps for releasing applications. For example, developer, test it, deployment, all this to be done quite faster. And hence, all the companies are moving into containers because of these reasons. One is standard, lightweight, quicker, and it is cheaper. Yes. And how do you manage these type of boxes? Not one box. You need to have multiple boxes like this. That is where you use Kubernetes. So we are in that process. Many people, many companies, you can still, I think, like say 40% of companies, they are trying to completely move on to Kubernetes these days. Now let's consider that you want to start using. So now we got a basic idea. So Kubernetes, the main difference is the pods. You don't manage single containers as a separate one. You manage them as a pod. So a pod can have single container or multiple containers. Let me again show you this diagram, and I'll come back. So a pod can have a single container, multi-container with a shared storage, something like this. So minimal unit you can create inside or manage in a Kubernetes pod. And the pod's IP address is shared for your containers using different ports. Yeah, will again come back to this so that I just want to show you because that is there in the architecture diagram we want to understand. Now, how do you start with your Kubernetes? The first thing is you need to understand it is like a server client. So this is your master. So this is a master. So you would, example, I would use a VM, okay? And I would download a software called as KubeADM. Let me use, I would download a software called as KubeADM. The different softwares for installing Kubernetes. If you want to have only one node cluster in which I want to use that a master and a worker node, I can use something called as Minikube. So Minikube is a single one. And if you want to have a full-fledged cluster like this, in which I can have one master and multiple worker nodes or slave machines, and to use software like KubeADM, or you can use KOps, KubeSpray, lots of software out there. So Minikube is wherein one machine, it can act both as a worker node and a master node. So it can schedule the containers on one box itself. Yes. And Minikube is for sandbox environment. Use it for testing your applications. Yeah, so Minikube is a single node cluster. Use single node cluster just for experimenting to work with Kubernetes, use Minikube. If you want to have a full node, because in enterprises, you cannot rely on one machine, correct? You need to have a multiple machines to be managed. So if I have an applications, I need to have an application, one more also in this, so that if this application goes down in this, I can still get it recovered in this. And for that, you want to use something like KubeADM software, using which you can create a cluster like this, a cluster. So how do I start? I start with the master. So example, I would install KubeADM software. And if I initialize this, it gives you a token. I get a token. And this token would get an I node on the token. It will also create 4 components. What are the 4 components? One is the API server. So in your Docker and Kubernetes is all about your API interaction. So any users or these machines, they communicate to the master using to an API. So you need to mention the API version. There's the API server. This is one pod which gets created. Scheduler is Let's consider that this guy say that I want to create 3 pods. He says that I want to create 3 pods. So it will go to the API server, the request, the scheduler will come to the picture, and it will decide whether to create the pods onto this worker node or to this worker node. That is your scheduler. Are you clear what is scheduler? Repeat once more. So if any request of number of pods goes from the user, it is the API server. API server sends a request to scheduler. The scheduler will get the information from the storage called etcd. It is your distributed storage. It contains all the configuration information about all the cluster. It gets the information, and based on the resource availability, it will either schedule the pod onto this or to this. It will just go ahead and decide which worker node or the backend. And the agents running on this called as kubelet is going to create the containers inside the pod. The schedule is all about to define in which particular machine it has to create your pod. Third one, etcd is going to contain the cluster storage data. All the configurations is going to contain etcd. It's a distributed key value store. Something like you can think about like a MongoDB or DynamoDB, the key value storage. Very, very flexible, very scalable, and very, very good to be used. etcd is a controller. It is your storage. And controller manager is going to keep track of the desired state. For example, you had 2 pods. For some reason, one of the pod goes down. This can help, the controller manager can help to create one more pod automatically. That is your controller manager. Now you need to first create this. So once you get that token that talked about, you get a token. Once you initialize, you get a token. You also create a kubeadm software on these worker nodes. And how do you become a cluster? You join the token. So you get a token from the master that talked about into a kubeadm init. You're going to get a token. And you run the token on the worker nodes, then become a cluster. And these are the agents. Kubelets are the agents running on every machine, but in your work nodes, these are agents running onto it. So these are the agents which is going to pull in the appropriate images for a container and is going to ensure that is up and running on your worker nodes. CAdvisor use it for advanced health checks. And kubeproxy use it for either to work with the services or to define the rules, what you want to allow for service discovery. You can use all of kubeproxy. And to communicate the pod, so this pod want to communicate to this pod, you need to network. That is called as a network called as overlay network. So across the box, you take a network called overlay network. For this, you use CNIs. So CNIs are called as container network interfaces. Like we have BeavNet, then Flannel, different vendors are there. That is how it starts. I repeat once more. You first install kubeadm, which will also install along with Docker. You install it together because you don't want to have a conflict between Dockers and kubeadm. Install both together. Once you install and initialize it, it'll create these these are the 4 pods it gets created. You get a token. You also need to have a kubeadm installed on this, but you don't initialize it. You run in the token on these, they become a worker node. And anytime from next time, I will not be able to create anything. So if I want to next time, if you want to interact directly, I cannot interact onto this. Any interface will be to the master, and the backend is going to get created either on this or onto this. That is how it works. But you can still run into Docker commands inside this, but you cannot use these directly to go ahead and create your containers. That is how the management is all about your masters. The backends are these. This is how you start your journey. Are we clear in architecture? Any questions? Now let's look in a cluster. So cluster is made of master and a set of worker nodes, and master is your front end, which consists of multiple important components talked about, and also called a control plane. And again, you can integrate with the cloud. You can use one more controller manager called a cloud controller manager, wherein you can integrate with your Azure load balancer, AWS load balancer, lots of things you can integrate outside. And node is a machine, which is a backend, which is where your application is going to run it. It could be physical or a virtual machine. And the kubelets are the agents running on all the boxes. Master API server, all about interface, scheduler, controller manager. Not only for pods, even one of the nodes goes down, your node replication controller is part of a controller manager, using which Even it can manage the nodes. And etcd is for persistence, very, very critical. So in enterprise, what they do is they would take in a very backup very regularly, or sometimes they would have etcd outside this itself. They have a separate component because they don't want to interfere etcd along with this. They'll have a separate etcd component so that it is quite secure. So very, very critical component, and you need to take a backup of it very regularly. It's a product of Core OS. So Core OS is one of, again, a company from which it is created. We're going to use the concepts of Core OS for the etcd. And agents is running on all of them, but normally talk about nodes because they refer for it. So kubelets are the agents running on the nodes, which is going to, for example, pull in the image and it's going to create the container. It's going to see about any health checks you want to do it done by kubelets. And kubeproxy is all about how do you want to access the services, the rules, those in the kubeproxy. And container runtime are the different types of container softwares which you can use it on Kubernetes. So for example, in this, it is not always that I need to use only Docker. So in this, I can have one for this could be Docker, this could be different one also. But when you go for examinations, still they are you need to know only Docker. And hence, most of courses these days is all about how you can manage Docker hosts rather than the other types of container environments. Yeah. So very brief about these components and what is a pod. So the pod, one, I can have a single container, multiple containers like this. So why do they use pod? So let's consider that you have an application like Node.js or whatever application, think about any application. So this application can do multiple purposes. So if I am going to have one container, but I get in different type of request, like example, front end might be or something, multiple opportunity done on one container, it might slow down the performance. So what pod allows you to do is I can have two containers which are very, very similar. Very similar, they can work together. So of the same type, I'm talking about not like database and Apache, no. Both web servers or both same app servers, they can work together and they can share the information. And hence you have an option to create multiple containers and they can have a common storage. That is the reason they're using pods, which will give you more redundancy sometimes or more efficiency for with it. They have defined something like this. And the containers, they use the shared pod IPs. So all get in the IPs of the pod. And these containers I talked about, they do not have persistent storage. So again, you might want to use some external volumes in the cloud. You can use it, or you can use in some options of having a shared path on your host machines. Lots of different options you can use when you work with your Kubernetes. Yes, this is in brief about what is the Kubernetes and this thing. Let me do a demo to show you how to work with your Kubernetes. So what I've done for this demo is I've used EC2 instances. So T2 medium is required minimum because normally requires 2 vCPU and 4 GB RAM is required for a master minimal normally. So use T2 medium. And for worker nodes, I've used T2 micro. So first I created a master and went ahead and did all the steps. For example, I went ahead and installed all the software of kubeadm. I installed disable SE Linux. I installed all the ports which required configurations for kubeadm. All this being done. I installed kubeadm Docker together. Then started services. Similarly, I did, and then I did an initialization. This is how you can create your just on a high level. So you do. So we'll learn more about this when you do the actual course. As of now, understand that you're going to install kubeadm and Docker on the boxes, initialize on the master, get the token, and you go ahead and configure it. So once you have the cluster ready, okay, master. So how do you confirm it is created? Get nodes. You see it is ready, working on all these things. And the components of a master. So I've done one for testing. So you see one pod created, all these are running. And the one, it means that each of the pod has one container running inside this. So it has scheduler running, proxy running, AWS are running, all these things. And how do I test it? So for creating your pods, you have two options. Either you can use an imperative or a command line or a declarative options. So if for simple example, if you want to create a pod, I can say kubectl run pod name like a pod 2. and I need to have a container of image of like Nginx, for example. So I create a pod. It says pod got created. So it would have made an immediate entry to etcd, and it would have scheduler would have gone ahead and created a pod. Let's see now. So how do we see the details? So the kubectl gets pods. We already had a pod before, so it's showing you 1 out of 1. So let us see this information. I want to see more information about this. So how do we see kubectl describe? So you want to see more information about that pod, describe the pod and type in the pod name. So pod 2. So when you describe, you see under that first one, you see here what happened. So scheduler decided to which worker node it has to do it. And the kubelets running a worker node, it pull in the image and create a container. And you can see all the information about it, where it got created, namespace, default namespace. The namespace is normally a part or where you can define that I want to run in a specific namespaces. And it's an IP of the container, so the pod and the container details, all you see it is there. And now one by one, you see it in here. It means that it is using one container, both it is running. That's a one by one. So now if I do not want the pod, I can delete the pod, and the pod name. It's gone. So for that to be done, you can also use a declarative file. So I can use declarative file in which I can mention about what type of pod I want to create. So when you use declarative, for example, I can define I can have multiple containers, same session, I can repeat container session. For example, I can do this, I can again do this, I put some other image, all this, I can use it. So I'll show you this file. So let's see about how to create using a declarative. Declarative is more preferred because enterprises, you want to reuse the applications. So something a template, you're going to have it. So I'm going to create one more pod using a declarative using YAML files. So Kubernetes is all about YAML files. So I copy this, do this. So what are defining in here? We are defining the API version details. Then the kind. So we are going to create a pod. Name of the pod is Nginx. Name of the container is Nginx. Which image I want to pull for the container Nginx latest one, and which port I want. This is all your container specifications. So define this. So now I'm going to go ahead and run this file. So running this file, like Docker commands, so Docker commands use a command called as kubectl is the interface. So I say that I want to create that. So create -f stand for file, the file name. I do a YAML file. It gets created. So now how do I check the same? I need to do a get pods. You see it is running in. Name of it, metadata, match, one container running, 6 seconds back. And now I see a describe pod, and I will see the information about the pod. The same happened, worker node. All these things you can see. And how do I know which worker node also, for example, if you want to see more information, I can also use a write option to directly see whether it got created. Worker node 2. Now, how do I check it got created? I can go to worker node 2, worker node 2. And now, for example, see, I cannot run any commands in here because it is not installed. For security reasons, we don't have it done. You cannot see any of the commands of master, you can do it. But you can still see the containers created. So Docker PS will show you this. So for example, this is your pod got created. You see this pod container, which will have the pod name. And I can also log into the pod. If I want to log into the pod again, I can do Docker execute -it, the pod that I can use it, and some / prompt. Let me use Nginx. Sorry, using Docker command. So sorry, the kubectl execute pod, and you are inside this. inside the pod. So syntax is kubectl execute -it, the pod name and the shell prompt. If you have multiple containers, you also need to mention the one more container name also. So I'm right now inside the container of Nginx. This is how I log in, and I can do all the operations. So I can do all the operations. For example, I want to update. Yeah. So I need to do some modification for DNS. Then you can also do update and other things. You can do it once you're inside the pod. This is how you work with your pod. And once you're done, exit. And I want to delete the pods. So kubectl delete pods -or. That's it. It is gone. So this has been very brief about how you work with your pods. Yeah. So we have a batch to start on Kubernetes and security, in which I'll talk about multiple modules, most related to certified Kubernetes administration. And administration also will have modules of security. We also include both of them. And the course is starting from May 22nd in weekends, which is IST 7 p.m. to 11 p.m. IST in this weekend. 40 hours, you're going to get class recordings, you're going to get lots of materials from me, slides, and trainer guidance. In between, you're also going to be a part of WhatsApp group in which you can get guidance and more information. And let me also show you the course details, more about it. So this is your course detail, in which you can find more information about, link also anywhere given the chat also. Information about the course, 40 hours, how to install and configure Kubernetes, working with Kubernetes architecture, and the batch starts on 22nd of May, weekend batch, 7 p.m. to 11 p.m. IST. It's open, going to get lots of learning, and it's mostly concentrate on a CKA, which is one of the valued certifications, and is for anyone. Why certification? All the details you want to know more, so we will give you. Requisites: knowledge of containers and Dockers, basics of virtualization, Linux basics, and basic knowledge on working with some applications. And this is about exam. We're talking about CKA exam. The contents, we're going to learn about what is CKA exam, what is Kubernetes, Kubernetes architecture, how to install Kubernetes, working with namespace and pods, how to manage application lifecycle management like updating, then rollback, all those options using deployments. How do you manage secrets, passwords using these, scheduling, storage management, controllers, networking, securing, logging, and how do you use like Docker Hub, you having some options to manage packages easily using Helm. How do you troubleshoot or work with Kubernetes maintenance, and the exam practice. So these are the topics which you're going to learn, which is very much aligned with your certification, and I'm going to give you the tips. Yeah, this is all about the course details. Thanks team for attending, and looking forward to teach you all. Thank you. Bye. All the best.